Hi everyone. Because we don't have regular class this week, I thought I'd spend a little time doing some of the things I was going to do in class here in a video. So this week we're going to be talking, or this week you're going to be working on Module 9, which is all about spread, really, about variation around the median. We're going to start, I'm going to do this in context of some data here, and these are 93 cars. And so I'm going to make a plot here like you know how to do. Let's get the plot, make it a little bigger so it's easier to understand and see. Then I'm going to put a categorical variable on the side. I'm choosing manual transmission versus automatic. And I'm going to stack those so they look nicer. And then I'm going to choose the city miles per gallon to put down here, a quantitative variable on the bottom. I'm going to spread those out like we've done before. And so now if we were going to describe these distributions, let's start with the automatic transmissions down here at the bottom. That's pretty much a symmetric distribution. And so we might use the mean as our measure of center. One way we could, and by the way, no outliers, if we were going to say where the center is, we might say it's 18 or 19, and the typical range maybe is 17 to 20, something like that. Some people might say 16 to 21, somewhere in that range. And we can confirm some of these things if we want to. We can put the median in the distribution. Notice the median will be here on 19. And the mean, and notice that the mean and the median are in the same, or pretty much the same locations, and that is actually confirmation that we have a symmetric distribution. I'm going to take those out for a minute. So there they are, or I'm going to put the median back in, and we can actually show the values of them. See, it's 19. If we put the mean in, it's almost exactly the same, 18.9375, which of course is very close to 19. So again, that suggests it's a symmetric distribution. On the other hand, when we look up here at the manual transmissions, the stick shifts, if you will, we see a distribution that is a little more complicated and does have some outliers out on the right side. It suggests that it's skewed to the right a little bit. If we put the mean and the median in there, and I'm going to take the numbers out for a minute, what you're going to see is that the mean is to the right of the median. That suggests a skewed to the right. When the mean is to the right of the median, that means that we have a skewed to the right. And if we put the numbers in there, we can see that the median is about 23, or is 23, and the mean is a little bit bigger than 24. Very nice that Boxplots does this for us, don't you think? Okay, fine so far. Let's add some other things. Oh, before we go on, we need to think a little bit about if we were going to compare these two, what would we talk about to use measuring the mean? Well, what we would do, since this one is symmetric, we could use either the mean or the median. They're both about the same. And when they're symmetric, we usually go ahead and use the mean. But this one, we can't use the mean because it's not as good a measure of center since we have a skewed distribution. That 23 is really a better measure of center in a skewed distribution. That is to say, the median is a better measure of center in a skewed distribution. So I'm going to take the mean away, and if we were going to compare centers, we'd say that the center of the automatic transmission is about 19, and the center of the manual transmission is about 23. Very good. Then, if we want to, we can add the box plot. And that is right here. And so you see a box plot. Now, we haven't talked about box plots, but you're going to be learning about them this week. What you're going to see is that this is the minimum value right here. And then here's the median. And then here's the maximum value. You're going to see that down here too, the minimum, the maximum, the median. Since we already know what the median is, it's easy to tell. The minimum, it looks like that's 15, but we can confirm that by putting a reference line in, right up here, and then moving that reference line right over here And sure enough, that sure looks like it's on 15. The maximum, we can also see right over here. And that looks like it's on 24, or very, very close to 24. We can confirm that also by just clicking on there, and that tells us 24 there. We can do the same thing here. We could move this over to here and say, well, that must be 46. Of course, clicking on it also tells us 46 over here. And then there are two other spots that we learn about here, and that is the Q1, that's what they call it, right there, which is on 20 for this distribution, and on 28 for that distribution. So right now we have a couple of things here. I'm going to do a little bit of typing. So for the manual transmission cars, the 5-number summary, which is graphically represented by the box plot for the manual transmission cars, is 15 miles per gallon. And then what did we say for the Q1 right here? 20 miles per gallon. And then the median is 23. And then the Q3 is 28. And then the the maximum is 46. We could do the 5-number summary for automatic transmission cars. And we could see that that is 15 again. And then looks to me that we have 17. And then 19. And then, oh, that looks like it's right in between. 3 right there, right in between. That's 20.5. And then finally 24 for the maximum. That's enough for this video. Let's stop there and we'll do some more things. But I wanted to give you a sense of how to use how to make a box plot, and then also how to see that 5-number summary in the box plot. Hope that helps for a start. I'll try to make another video to talk some more about what we see here.